Hi, so welcome to this video lecture in dynamics. So for this video, we're going to talk about the distance versus time graph. Second is we're going to also going to learn about velocity versus time graph, and then rectilinear motions. So here functions are expressed with respect to time. So it's going to be an equation. And also free fall, and then last is projectiles. So what you see here in the bottom are the formula that we're going to use for this topic. Okay, so let's talk about distance versus time graph. So the distance versus time graph, basically from the name itself, graphs, is a representation of the relationship between distance and distance. Let's say distance is x, and then time. So let's say that we have a distance of 1, 2, and 3. Okay, and our time is 1, 2, 3, 4, 5, 6, 7, 8. Right? So let's say our position. So what are we dealing here? What are we dealing here? So we are giving the representation in graphical form the behavior of a particle. So let's say this is our particle. Okay, so let's say at time 0 our particle is seen at a distance of 3. Sorry about that. So let's say start from 0. Then after 1 second, we've seen it move like this. After 2 seconds, move like this, and after 3 seconds, it moved like this. Okay, so basically the particle behaves in a straight line. It means that, for example, this is your motor, this is you, and you walk, and you are currently walking at this direction. Okay, so 0 at time 0, and after 1 second, so you move 1 meter. Okay, for example, this is you. So this is you at 0 second, and then after 1 second, you move by 1 meter, and then another 1 second, so you move again another 1 meter. So you're here after 2 seconds. Okay, so what is this in a graphical representation? So it's only like this. Okay, so you can see here your position changes in time, and that's linear. So you're seeing a linear change, and since this is a linear change, we can always use the value of the slope of the line, and that's, my friend, is the slope. Okay, so we're going to review the formula, this formula in analytic geometry. So the point slope form, slope intercept form. Okay, so m, or slope, is the change in y over the change in x. Okay, so for example, if we're going to find the slope of this one, of this line here, the slope is gonna be, let's say our first is, okay, let's say our last is 3, our initial is 0, and also our last is 3 seconds, and then the initial is 0 seconds. So 0 second, so we have 3 over 3, and that's 1. Okay, so your slope is 1 meter per second. So that's your velocity. I'm sorry, did not specify here. But the slope here is actually the way the change in position over change in Gwen? Yan na pa may sumisigaw sa iyo eh. Ang bingi naman ito. Change in position over change in time. So that's slope. And that is basically the velocity. Okay? So, how do we translate this to another kind of graph? So, take note, this is simply, what I'm showing you is simply the distance versus time graph. So, this is not yet the velocity versus time graph. So, the velocity versus time graph looks like this. So, velocity and time. So, let's say at time 2, 3. At time 1, or at 1 second, our velocity, that should be the same. So, 1, 2. So, our velocity did not change. No? So, we have seen a constant velocity. So, this is the only representation of this one. So, from this line, now we have a straight line here. Because our velocity is constant. It did not change. So, this is the velocity versus time graph. Okay? That's a velocity versus time graph. Now, further expounding this equation, let's say that this representation, let's say that another chance took place. So let's say that the particle suddenly changed its position. So let's say so this is its last up. Oh, sorry. So let's say that this is the last position. Okay, and then the driver seemed to change his mind, and then he constantly just being consistent at this moving at this kind of behavior. So so starting 4 seconds, he simply just maintained his position. So he basically changed, right? So basically he did not move. If you're going to think about it, he did not move. Okay, so sa Tagalog, hindi gumalaw yung ating driver. So, for example dito, so paano ko nalaman na gumagalaw siya? Kasi nga nagbabago yung position natin. So, habang tumatagal, nag-i-increase yung kanyang position. Now, this one, papansin nyo, hindi siya gumalaw. Kasi nga, yung position niya is still at number 3. So, doon pa rin siya sa position 3. Pero yung time, tumatakbo. So, this is 4 seconds. So, what does this looks like in a velocity versus time graph? So, what does this look like? Okay, so 4 so let's say this is 4, 5, and 6, and then 7. Okay, so first instance during the first 3 seconds, so it only moved, so it has a constant velocity like this. Okay. Now, at 4 seconds here, up to 7 seconds, what is its velocity? Okay. So what is this velocity? Now, looking at this straight line, we all know that the slope of a straight line is 0. So basically, he only made this kind of leap to the 7th seconds. Okay, so it's actually, the line looks like this. Okay, so that's it. So the velocity is consistent or constant at 3 seconds, and then after 4 seconds it dropped and then maintain its position. So this is basically how we interpret velocity versus time graph and distance versus time graph. So all you need to remember is the slope. Okay, so again, if you see a straight line, you see basically see a 0 slope, which means that the object did not move. Because again, it did not move. It stayed at the position 3 meters. Okay, so that's it. I hope you get the point. Okay, so moving on. Sorry about the interruptions a while ago. Okay, so number 3, rectilinear motions expressed as a function of time. Now, as I already discussed a while ago, there are position versus time graphs. Now, a particle behaves like this, like this, like this, like this, or sometimes a particle actually behaves differently. You know, a particle sometimes behaves like an arc. Sometimes it behaves like a exponential form. Sometimes it actually behaves like a parabola. Sometimes it looks like this. So this is simply just the representation. So here, so if you see, if the behavior of a particle is like this, so you're seeing a parabola, so expect that there is some kind of squared function. So this is basically a function. So this is what is all about. So because there are positions of particles that does not behave in a linear fashion like this. So sometimes particles behave like this, and like this, and like this. All right. So it's very difficult for us to determine the slope of that kind of behavior of a particle, because again, slope can only be used when you're going to talk about linear or lines. But if we're going to talk about arcs like this, so how do you measure the slope? So it's different. So for this one, you're going to need the help of integrals and differentials. Okay? So for example, the position of a certain particle is given in terms of formula, wherein S as the displacement is equivalent to 5t plus 4t cubed. So if we're going to graph this one, okay, let's try to graph 5t plus 4t cubed. Okay, 5x plus 4x cubed. Okay, so see, so you're not seeing you're basically not seeing a line here, but you are seeing somehow like a line, but it's not actually a line. So this is a very weird function, isn't it? Okay, so this is practically useless for you if you're going to use the slope form, which is dy over dx. Okay, But you don't have to worry though, because we all remember that derivatives or differential is basically from the word changing, and the slope is also derivative of something. Now, since we cannot use slope forms, or basically dy over dx, we use our differential functions. Okay, so let's say, for example, if we're going to use this one, the position of a particle is given in terms of 5t plus 4t cubed. Okay, so again, remember, velocity is the change in displacement over the change in time, and acceleration is the change in velocity over the change in time. Okay, so if we're going to talk about this one, what is the changing particle with respect to time? So it is basically velocity. Okay, so expanding this equation, we can also say that velocity is also equivalent to the delta s, or simply saying s prime, and the acceleration is basically just v prime. Okay, so if we're going to do the s prime, okay, so we're going to do the chain rule. We're going to differentiate this whole function with respect to time. Now, the s prime is also equivalent to the velocity, and that velocity is equivalent to ds over dt. Okay, now since we're looking for s prime, or velocity, now differentiating s with respect to time is equivalent to 5t plus 4t cubed. Okay, so velocity is 5 plus 12t squared. So this is the velocity, but this is not yet the velocity. This is just simply the formula. Okay, so if we're going to do v prime, and v prime is acceleration. Okay, so v prime is acceleration, so v prime is equals acceleration is equals to the differential of 5 is 0, constant. The differential of 12t squared is 24t. Okay, so I forgot that v prime is also equivalent to s double prime. Okay, so s prime is velocity, s double prime is acceleration, v prime is also acceleration. Okay, so using this formula, so these are our formula. So from this particle equation, we can get the velocity and the time. The acceleration. The velocity and acceleration given its time. Okay. So in any particular time, what means to say is, in any particular time we can get the velocity and the acceleration. Okay. So that's how you do it. Follow-up question would be, what if acceleration is given? Okay, acceleration is given, and we're going to find velocity and time, and velocity and the displacement. Okay, so if you're going to remember what I talked about earlier, if we're going to differentiate displacement, we will get velocity, and if we're going to differentiate velocity, we will get acceleration. And we all know that what we did is differentiation. So we're using derivatives. Now, anti-derivatives is integration. So, in order for us to get velocity, we will simply integrate v prime and turn it into v. And then, since we are looking for the velocity, if we're going to get the displacement, we will integrate s prime, and then we're going to get s. Alright, so if we do not follow, basically what I'm saying is, you have to remove the prime. And to remove the prime, you will do integration. Okay, so how do we do that? So example. So this is a very tricky one. So this this process is actually very tricky, because if looking at our differentiation, for example, if we're going to differentiate 5 plus 24t, okay, t squared. So it's very easy for us to differentiate it, because it's very straightforward. So if you're going to do s prime, okay, so s prime, I'm sorry. So if we're going to differentiate this one, s prime, so we're going to differentiate 5, so that's 0, and we're going to differentiate this one, so it means it's 24. 24 times 2, which is basically 48. 48. So this is 48t. Okay, so this is quite easy. But the problem is, if we are going to do this the opposite way, okay, so for example, we already know that the acceleration here is 48t, right? Now, as I already said before, to go back from acceleration to the velocity s prime, to go back to the s prime, we're going to use integration. But the problem with integration is, every time that we do integration, we will get a new kind of variable, which is c. So for example, if we're going to integrate this one, we will get plus c. If you remember integration, okay. So let's try doing this one. Okay. So actually, we already know that acceleration is the change in velocity per change in time. This is 48t. Alright. So first thing we need to do is to move dt to here. Okay. So dv is equals to 48t dt. Alright. So we need to do anti-derivatives, so we use integration. We integrate both sides, and if we're going to integrate this one, we will arrive to v. Okay, so integrating this one, constant is 48, so integral of t dt, so v is equivalent to 48 t squared over 2 plus c. Alright, so this is basically v is equals to 24 t squared plus c. If we're going to check this one out, this is the value for c, 5. But what if we don't know this one, and all you know is this equation? So this is another problem for you, because you don't know the value of c. Alright, so that's where another values come into play. So all you need to remember is that when the acceleration is given in terms of time like this, and you're out to find the velocity and the displacement s, in the problem there should be given another set of values like this one. So what you see here is that there are other values that needs to be inputted. Okay, so we're going to substitute this one, and we're going to substitute these far values in order for us to get c. We have to find the value of c. Okay, Now to do that, we use the set of values that was given to us. Okay. Example, displacement or s is equals to 4 meters, and then velocity is 2 meters per second, and time is equals to 1 second. Okay. So we stop at this equation because we're going to find the value of c. Okay. So velocity is given as 2, and our time is given as 1. Okay. Time is given as 1. So 24 1 squared plus c. So 2 24 c is equals to no, sorry. Hindi yata mag-eksakto yun. Iba nga pala itong problem natin. 48 nga pala to. Hindi nga pala to. Hindi pala to 2t. Okay. So, continue na lang natin. So, let's try to use another example. I'm starting from scratch because yung ginamit ko kasing value 48t is dapat talaga may kasamang value yun. Okay, dapat may kasamang ibang value. So gamit tayo ibang problem. Okay. So example, this one, particle is given in terms of 40 squared. Okay, and you are going to find the velocity and displacement when t is equals to 2 seconds. Okay, so again, acceleration is dv over dt, and that's 4t squared. So dv is equals to 4t squared dt. So integrate both sides. So we have v is equals to 4 third t cube plus c. Okay, so we stop here. We stop at this equation. Now we're going to use another set of values given in the book. So which is t is equals to 0, v is equals to 2 feet per second squared. Now we're going to use this one in the equation. So this is the reason why I need to stop and change the example, because there is no value that there is no value that I given. It's really difficult for us to get the values. Anyways, since when time is equals to 0 and velocity equals to 2, so velocity is 2 4/3, and then our time is 0. So basically 0, and then c is equals to 2. Okay, so erase. Now we know that the value of c is 2. Okay, so at time is equals to 2, substitute this one. So v is equals to 4/3, 2 cube plus 2. We arrive at 2 times 2, 4 times 8. So 8 times 4, 32 over 3. So 32 over 3 plus 3, 2, 3. So 6. So 6, 38. 38 over 3. Yeah. So we have 38 over 3. Okay. So that's the velocity. But are we finished? Are we done yet? No. Oh, okay. So that's the velocity. So we need to find s. We need to find s. So we already good with the velocity. Okay, so to find s, again, we know that the velocity is the change in displacement over change in time. So ds over dt is equals to 4/3 cube plus 2. Okay, ds is equals to 4/3 t cubed plus 2, then enclosed dt. Okay, so integrate both sides. S is equals to, okay, so 4/3 plus 1 over 3 plus 1 plus 2t, okay, plus c. Okay, so another problem is that we arrive at another value for C. Now, again, we substitute at S is equals to 4 and time is equals to 0. So S, 4, time is equals to 0, so basically 0, 0, so C is equals to 4. Okay? So, kanina kasi meron tayong hindi nagamit yung S. Okay? Yung nagamitan dito is T and then yung V. So, dito S. So, since alam na natin ang value ng C na yan ay 4, okay? So, again, we substitute at T is equals to 2. So, S. So, simplify ko lang ito. So, this is 4. And this is 4. So, cancel. So, we arrive at 1/3. T to the 4th plus 2t plus 4. So, we have S is equals to 2 is to 4 times 2, 4, 8, 16. So, 16 over 3 plus 2, 2 plus 4. S is equals to 16 over 3 is 5. Yeah. So, within. So, we have 16 over 3 plus 4 plus 4. Okay. So, we have 16 over 3 plus 8 over 3. So, this is S is equals to over 3. 8 times 3, 24. So, 0, 40 over 3. Plus 40 over 3. Okay, so yan, 14 over 3. Yay! So, our velocity is 38 over 3 and 40 over 3. So, again, napapansin nyo, no, medyo tricky itong problem na to kasi marami tayong value ng C na kailangan tanggalin at kailangan hanapan. So, that's where kailangan talaga pumasok na meron tayong predefined values for the, may mga predefined values tayo. Kasi without this, hindi natin makukuha yung exact na sagot na hinahanap, yung sagot na hinahanap natin. So, that's it. Okay? So, that's rectilinear motion using particle motion, yung rectilinear motions using the three formulas. Now, we're going to proceed with rectilinear motions along the x and y axis. Okay? Alright. Linaw na. So, looking at this formula here, okay, kapansin nyo, gumagamit tayo ng x. So, it means that particles move along the x-axis. So, if you're going to if you're going to talk about the particles that moves along the y-axis, so hindi na x ang gagamitin natin, kundi h. So, all you need to do is to simply replace x with h, and at the same time, replace a with g. Gagawin yung g yan. Alright? So, bakit ganun, sir? Kasi, sa mga motions along the y-axis, yung mga nahuhulog, ang nag-come into play really is the acceleration due to gravity, which is g. And g is 9.81 meter per second squared. So, this is universal for Earth. So, obviously, kapag nasa, this is Earth, and this is Moon, so iba ang g pagdating sa Moon. Okay? Diba? So, before that one, let's talk about rectilinear motion along the x-axis. Oh, free fall. So, free fall is basically everything that is along the y-axis. So, that's free fall. Okay? So, for example, meron kang nakasabit na salamin. Okay? Salamin dyan. Tapos bigla siyang, tapos yung ginamit nyo na pangdikit, biglang nag-dry at tumigas. So, mangyayari, mahuhulog yung salamin at mababasag. Okay? So, that's a good example of a free fall, because a free fall is basically saying it's falling freely. Alright, so there's no restriction on the movement, so it's just falling freely. Now, you might be wondering, are free falling objects really just basically falling objects? I mean, what I mean to say is, are we only going to talk about the objects na nahuhulog lang ng kusa, or pwede natin sabihin na yung mga hinuhulog pababa? Okay? So, pwede yun. So, we're also talking about the two. So, it's basically the same thing. So, for example, kapag meron kang binato na, for example, meron kang ikaw yan sa bundok, may ikaw yan, tapos nagtapon ka ng bato, so, yung bato na yon merong initial velocity yon. Ibig sabihin ng initial velocity is, hindi siya nag-start from rest. Okay? Kasi, on the contrary, ang difference nito at nandito, kasi ito, nag-start from rest. Okay? So, let's try examples from rest. Okay? So, let's say that this mirror is hanged 2 meters from the ground. Okay. So, the question is, the time it will reach the ground. So, find the time that it will reach the ground. So, given that the height of the mirror is 2 meters. Okay. Now, looking at the formula here, we have this 1, 2, 3, and 4. Okay? So, if you're going to ask me, we're going to replace delta x with h. Okay, this one, h. So, from this set of formula, what are you going to use? Of course, you're going to write first the given. So, givens. So, we have height, which is 2 meters, g, which is equivalent to 9.81. Now, question. Do we really have to consider the weight of the mirror? Do we have to consider the weight? Do we? Now, this is a very intriguing question, because going to look at our equations here, if we're going to look all of our equations in kinematics or free-falling bodies, we don't see mass. And why is that? Okay, so to answer that question of mine, all we need to do is to remember the experiment of Galileo Galilei in the Leaning Tower of Pisa. Okay, I'm sure you already know the story. So let's say this is Galileo. So Galileo dropped two different objects with different mass, wherein the mass of first one is greater than the mass of the second one. So he said that they both reach they both drop at the same time. So that the time for the mass 1 is equivalent to the time for mass 2. So that's the experiment of Galileo Galilei, and modern scientists and astronomers did the same thing, experiment in space, and they found out that Galileo is actually correct. So despite the weight of two objects, even if they differ, they both will fall at the same time. Both speed and same speed at the same time. So in problems of kinematics, we don't really use mass because they will basically fall at the same time. I mean, mass is irrelevant because even if they have two different kinds of masses, they will fall at the same time. Okay. So this is the reason why there is no mass in our equations. I hope you get that one. Now we have H and we have G. Okay, so looking at our set of formulas here, what are we going to use? So okay, so we have this one. So let's try to use this one. So H is equals to V naught times T plus 1/2 A. So again, if we are talking about kinematics or along the y-axis, we use G. Okay, not A. So not A. So G T squared. Right? So question is, do we have a V naught? No, because our our mirror started from rest. So our initial velocity is 0. Okay? So H is 1/2 G T squared. So substituting the values for the equation is 2, 1/2, 9.81 T squared. So 4 over 9.81 square root is equals to time. And that is square root of 4 over 9.81. So the time is 0.638 seconds. So it's quite fast. Okay? So that's the amount of time. Now that's free fall. Now, how about we step up a little bit? So what if you're here at the cliff? Okay. Oh, I'm sorry. Let's say that you are at the edge of a building. Okay, let's say this is a building. Okay, and the building is, let's say, 200 meters. All right, and then you started free falling. So you started free falling. You drop. Okay, so that's you. All right, so calculate the amount of time, or what is the time that you're going to fall. Alright, so this is basically the same thing, the same formula that we used a while ago. So H is equals to G T squared over 2. Okay, so the time is square root of 2H over G. T is equals to square root of 2 times 200 over so square root of 2, so basically that's 400 over 9.81. So 6 point. So the time is 6 point. Okay. Time is 6.38 seconds. So it means that it will took you 6.38 seconds to fall. That's 6.38 seconds. Okay. So let's say what if you're already here? Okay. What if you're already here? And you're already at a drop. You're already at a drop. Sorry. So let's say you're already here and you're already dropping at a time of, let's say, 6 seconds. Okay? And then suddenly, okay, so burahin ka natin dyan. Wala ka na dyan eh. So, and Superman came to the rescue. Alright? So came to the rescue. So you are already falling for 6 seconds. So you're only so Superman only has 0.38 seconds to catch you. Okay? So since Superman only has 0.38 seconds to catch you, the question is, how fast should be Superman go to get you? Right? That's a very tricky question. Right? But in order for you to answer this kind of question, you have to break down. You have to understand first. You have to use your imagination first. So you can see here, 3.38 seconds until drop. So it means that you're not yet falling. So determine the amount of time here, or the amount of height here. But regardless, Superman only has 0.38 seconds. So you only have 0.38 seconds to catch you. And he is at this height of 200 meters. Alright? So, ibig kong sabihin is, ano yung magiging bilis si Superman para masalo ka bago ka bumagsak. Okay? So, dapat masalo ka na niya. Dapat nga. Hindi dapat 0.38 seconds yan eh. Kasi sabay ko yung lalagpak, no? So, dapat bawasan natin. So, dapat masalo ka niya in 4.34 seconds. Kasi kapag 0.38, patay ka na, lagpak ka na dito. Gets nyo naman siguro. So, 0.34 seconds. So looking at our formulas. Okay, so we have alright, so we can use this formula again. But not really, because we don't have G. Right? And Superman should be increasing. Very tricky question, really. Okay. So, yeah, why not try to use this one? So, why not try to use this equation? We can use the equation. G is basically the same 9.81 because gravity will help. Again, let me explain. Gravity will help Superman to accelerate faster. Okay, so gravity is in play. So our formula here is the distance, let's say 200. So he will need to travel 200 meters. It's equals to velocity initial. This is the velocity that we're going to look for, and our time is 0.34. So plus 1/2. A is 9.81. Time is 0.34 squared. So our V naught and the velocity initial of Superman is, okay, using our formula, okay, Okay, so Superman should have a velocity of 586.57 meter per second. So, ganun dapat kabilis si Superman, no? Parang, parang ganun na, biglang, no, parang mga ganun, no? Bilis-bilis si Superman. So, I hope that you get the example here. So, we practically combine two kinds of scenario. So, free fall ikaw, so you're falling for 6 seconds, and Superman should catch you 0.34 seconds. Okay, so gano'ng kabilis dapat si Superman para maabutan ka at hindi ka malagtok at mabagok ang ulo at mamamatay ka. So, Superman should be 586.57 meters per second. Okay, so this is a very good example, right? So I hope you get the point. Okay, hope you get the point. And the last, good one, okay. So the last example for today is projectiles. Now for the projectiles, I'm going to require the help of PET simulations. Okay. I hope you really get the point. Examples here, really. Okay. So let's try to ask Google for projectiles. So PET simulations. Okay, projectiles, so motion, physics, motion. I'm going to look for letter P, projectiles. Okay, projectile motions. So let's try this one. Alright, so projectiles. So basically projectiles are, shooting like this. So we fire in the hole. Yeah, so we fire. So like this. Fire. Fire. So initial speed. You can say initial speed is 0, of course. It's not going to go anywhere because your initial speed is 0. Come on. 1, let's say 1. No. Okay. So why do we have like that? So we have to fire. Alright, we don't see anything. Okay, so going back, go to lab. Okay, so just an overview. Projectiles has at least 4 formulas. Okay, so H is for the height. Okay, let me draw. So let's say this is your projectile. Okay, so it will travel like this. So all you need to remember is that mass is already at play here, because mass is actually the thing that makes projectiles curve. So again, so is this due to mass of the object that it is actually bending like this. So for example, kapag hindi kasi affected yung mass, so it will just go outside the universe. For example, this is Earth and you're here, okay, and you throw a ball. So, kapag walang affect ng gravity, didiretso lang yun hanggang sa bumangga man kung saan. Okay, so since may gravity, mag-curve yun. Mag-curve ang object na yun hanggang sa mag-reach yung drop. Okay, so yun. So, that's projectile. Okay, so may tayo 4 na formula. So, we have the range. Ibig sabihin, yung range is kung gaano ka layo yung tapon, and our height is yung pinakamataas or yung maximum height, and the time is the amount of time. So that's 5 seconds. Okay, so that's it. So for this one, basically, all I'm saying is that there are times that the projectiles is, for example, you kick this one, syempre tatapon yung ganun, so meron siyang velocity. Okay, so Vx here is the component of the velocity on the x-axis, so which is yung velocity na pag ganito, and the y-axis is yung papataas. So that's the reason why nag-arc yung object. So ganyan ng, for example, ikaw yan, sisipain mo yan, yung bato dyan, so pag sinahipa mo yan, so tatalon niya ng ganyan. Tumaas siya, papansin nyo, tumaas siya, di ba? Pero tumatakbo din siya pa kanan. Kasi nga, meron tayong y component at meron tayong x component. Kaya ganun. Okay? So, let's do a practical application, shall we? For example, going back here, do really have to consider mass? No. Fire, fire. So, mapapansin kayo, no? So, mababa din, syempre kapag mababa yung angle, yung maliit ang angle nyo, maliit din yung height na mapwede nyo ma-achieve. Pero pag mataas yung height, mataas din. The problem here is, meron lang particular na value ng angle na kung saan magiging maximum yung height at maximum yung range. So, hindi rin pa na maganda na sobrang taas. Nabansin nyo, di ba? Hindi maganda sobrang taas. So, kahit sobrang taas yung angle at 69 degrees, hindi niya matalo yung 25 degrees kanina. But at least it has a higher amplitude. Pero, question here is, importante pa talaga yung height. There are some cases na importante yung height, but ang pinaka-importante talaga dito ay yung range. Because if you are using a cannon, so mas maganda yung pinakamalayo at pinakamalayo na pwede mo maabot. Diba? Mapapansin nyo, diba? Lalong lumalayo. O, lalo pang lumalayo. So, at 40 degrees, so tayo 43. Lalayo pa ba? Oh, yes, lalayo pa ba? Lalayo pa. So, 49. Okay, so pansin nyo, at 49 degrees, bigla na bumababa, di ba? Bigla na siyang, hindi na siya lumalagpas. So, the more na tumataas tayo, hindi na natin siya napapalayo pa. So, in this, lalo pa tayong nababawasan. So, ibig sabihin, ang ideal natin na angle is 45 degrees. Tama. So, 45 degrees ang ideal angle ng range ng projectiles. So, you have to remember that. Now, the question is why? Why 45 degrees, sir? Why? Why 45 degrees? So, okay, I'm going to look at this formula really. So, sine 2 theta. Sine 2 theta. Okay. So, we are expecting that the value of sine 2 theta should be equal to 1. Okay. So, shift solve nyo na lang, no? So, sine 2 theta. Ano yung value ng theta? Okay. So, any particular angle, no? 1 equals sine 2 so radian, naka-radian siguro to. Yeah. Page. Yeah. So 50 degrees. So sabi dito at 50 degrees daw yung 50 degrees. So let's try Google, no? Max angle projectile largest range. Okay, so 45 degrees. So it should be a 45 degrees angle. So kung pansin nyo kayo na 45 degrees, no? Wait lang, probably may mali tayo sa math. So sine 2 theta, hanap tayo ng iba pa. Sine 2 theta, sine theta, cosine theta. Yeah, 2 sine theta, cosine theta. Okay. So sine sine 2. Okay, sorry. Let's try sine 2 times 45 degrees. So 1, diba? So why can't we hit 100? So why is it 45? Why can't we do 50? Alright, we do 50. Fire in the hole. So baba, no? So why is it? Why is it that the maximum angle is a 45 degrees angle? And not 50? So sine 245. Sine 245 is 0.999. We're really weird, no? Sine. Okay, sine 245 is 0.99. Really weird. Really weird. Why can't we use 1? Anyways, that's a very interesting question, isn't it? Okay, anyways, let's try to use an example. Okay, so example number 1. Okay, so projectiles. So let's look at example. Okay, so projectiles. So projectile is any body that, given an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. Okay, so these are the formulas. Okay, so projectile motion range. So yeah. So okay, let's try this one. So a projectile was launched upward from level ground at an angle of 60 degrees with the horizontal. So it has an initial velocity of 45 meters per second. So how long will it take before the projectile hits the ground? So, but the question really here is, what should be the initial velocity, right? So what would be the velocity on the impact? Okay, I get now. The questions that involves impacts, velocity impact. Okay, so the very interesting question is, you know the impact velocity, so let's say v, but you don't know the initial velocity. Okay, now it is very interesting to know really that it's basically just like throwing a ball upwards and then expecting the same ball to go downwards, right? So let's say, for example, we throw a ball at the initial velocity of 5 meters per second and then yeah, so that's all that we need basically, right? So that's all that we need basically. So question number 1 is, of course, the ball will travel upward until it will stop. So the final velocity is 0, right? And then after reaching a final velocity, it will make a free fall. Then, right? Okay, so since our initial velocity is 5 meters per second, are we expecting the same velocity here at the final 5 meters per second? I'm sorry, 5 meters per second. Are we going to expect the same value? Very interesting, isn't it? So let's try it. So going upwards, the ball will have a final velocity of 0, but the initial velocity is 5. So in this kind of situation, we're going to find h and the time, or we can find both really. So looking at our formula, the equation, you can use the final equation here, right? So the v squared is 0. So since this is the final velocity, so final velocity, initial velocity squared plus 2g h, but this time we're going to use a negative sign because we are going upwards. So our enemy is gravity. Okay, so final velocity is 0, initial velocity is 5. 5 minus 2, 9.81, and then h. So we can find h. So h is sa kabila, so positive. So 5 divided by 2, 9.81. H is so our h is 5/2 times so our height is so 0.25 meters. So it only reaches 0.25 meters height. Okay, so let's try using this one going down. So the final velocity, so initial velocity, again we already the initial velocity, since this is already free fall. Okay, so dito na tayo sa pababa. So our height is the same, 0.25. Okay, so using the same formula, so V final equals to initial is 0, okay, plus 2, 9.81 times height, which is 0.25 48. Okay, so 2 times 9.81 times 4. So our velocity final is the same, 5. Wow, very interesting. So it means that if your velocity upward initially is 5 meters per second, you can expect that it will fall the same at the same velocity, 5 meters per second. So for the same, using the same token, we can expect that our initial velocity for projectile is basically the same as the final velocity. So our final initial velocity is the same as the final velocity for projectiles. For projectiles, if they are on the same level or plane. Okay, I would just like to reiterate that we are only talking about projectiles on the same plane. So we're not talking about the projectiles that goes like this. We're not talking about projectiles that goes like this. Okay, so on the same level or plane. Because if you're going to think about it really, it's just simple. It's the same as free falling. So, for example, this is your initial velocity. You will go upward, okay, and it will come to a stop. The ball will stop at velocity which is equals to 0, and then because of free falling, it will still go down, and then it will reach a velocity final. So this will be the same as this one. So if this is 5, this is also 5. So the time that it took to travel from this point to this point is also the same as the time that it traveled from this point to this point. Again, you have to remember. So let's say this is 2. So T1 plus T2 is equals to the total amount of time traveled. So that's the formula that we're using here. Okay? And the height here is basically the same thing here, h. Okay, so remember that initial velocity is also equivalent to the final velocity here, if we are talking about same level plane projectiles. Okay, so I hope that's clear now. Basically, I'm not going to use other situations or examples to use these equation or formulas, because again they're basically the same thing. They're just going to plug in the values here. So I think it's very easy for you to do. But the concept really here is that it's very tricky for you to understand that T1 plus T2 is the total total travel time, and the initial velocity going up is the same as the final velocity going down. So I hope that gets that very clear now. So I hope you get something from me, and see you around. Bye.